Is that okay?
Yes.
Okay. Good morning, dear colleagues. My name is Elena Padalko. Today I will be speaking on behalf of Dmitry Chimachenko and Vasil Chimko, representing our research COVID-19 misinformation detection and Weibo by support vector classifier. So, the COVID-19 pandemic has unleashed the parallel infodemic characterized by the overabundance of accurate and false information on the internet and social media platforms. This infodemic have been fueled by the global concern and uncertainty supporting of the virus, leading to the rapid dissemination of misinformation and disinformation. So our study aims to develop a support vector machine model for classifying misinformation related to the COVID-19 pandemic shared of the Chinese social network Weibo. We used check data set for the application of the misinformation classification model. This comprehensive collection of the microblogs from the Chinese social media platform Weibo was curated explicitly for COVID-19 misinformation detection. It is actually the first of its kind focusing on Chinese language content related to the COVID-19 pandemic. The dataset comprised two main categories of microblogs. First of all, is fake news and also real news, each containing several entries. Each entry in the dataset includes a variety of components such as microblog's ID, label by researcher like a real or fake data, posting date, user ID of the poster, textual and visual context of the microblog, a number of comments, forwards and likes, detailed information of the user comments and forwards, and an expert actually analyzes and justification for the label. It is only for microblogs, which was determined as a fake. In addition to the microblog entries, the dataset includes a list of keywords used to determine the relevance of the microblog to COVID-19. So the check data set is a valuable resource for researchers working on misinformation detection, particularly on Chinese language, because we are not expert in Chinese language. You need to acknowledge that. And in the context of the COVID-19 pandemic, which we are very much delighted and interested in researching. It provides a robust and privacy-respecting collection of the real and fake microblogs, expert analysis, benchmark results, and additional resources to facilitate further research in this critical area. So let's go to support vector classifier. It's a type, and we will call it SVC model further. It is a type of support vector machine used for classification tasks. It is a supervised learning algorithm based on the concept of decision plans defining decision boundaries. A decision plane separates between a set of objects having different class membership. Mathematically, SVC algorithm try to find the optimal hyperplane that separates classes in a feature space, as you can see it on the slide. The feature space is n-dimensional space defined by the n features used to represent each data point. The hyperplane is defined as n one-dimensional points. The hyperplane one n-dimensional subspace of the feature space. For a two-dimensional feature space, the hyperplane is a line, and for a three-dimensional feature space, it is a plane, or so on. The optimal hyperplane is one that maximizes the margin between the two classes. The margin is defined at the distance between the nearest data point of each class to the hyperplane. The data points that are closest to the hyperplane are called support vectors. That's why we call it support vector machine approach. As a support vector are critical elements of the training set because they define the decision boundary. Any data point of the side of the hyperplane is classified as one class, and any point of the other side is classified as the other class. And as you can see, it's on the slide, definitely. The SVC algorithm was adapted for misinformation classification using data from Weibo, a popular Chinese microblog web service. Weibo posts often contain a mix of text, images, and videos. Therefore, the feature extraction process must be adjusted to handle this type of content. In the context of Weibo, the feature space can be a set of the features extracted from the text, image, and videos of the Weibo post. For the text data, features can be extracted using the term frequency, inverse document frequency, TF-IDF values of words on the n-grams, sentiments, scores, or etc. The classes to be predicted are binary, for example, like fake news or real news, as I said previously. The SVC algorithm have trained on a label data set on a Weibo post to find the optimal hyperplane that separates the fake news post from the real ones in the feature space. Once trained, the model can classify new posts into fake or real categories. The process of model tuning involves several critical steps to ensure optimal performance. Initially, various models were tested by alerting only the kernel function and critical parameter in the SVC models. Among the different kernel function tested, the linear kernel emerges as the most effective, the most efficient, I would say, demonstrating superior performance in the preliminary trials. Subsequently, the comprehensive search was conducted for the optimal values of the remaining parameters. Specifically, the regularization parameter C and the kernel coefficient G, utilizing the grid search approach with a tenfold cross-validation. The grid search was performed across the range of values with a spread of the order of magnitude. 0.10 for each parameter. This approach ensured throughout exploration of the parameter space and ultimately identifying the most suitable parameter values for the model. Prior to the execution of the model, it was imperative to select an appropriate vectorization technique to convert textual data into numerical formats suitable for machine learning algorithm. After careful consideration, the FT-IDF vectorized was chosen for the two primary reasons. The TF-IDF vectorized is seamlessly integrated into skills-learned library, eliminating the need for additional post-processing. And second is, among the various non-deep learning-based vectorized evaluated, the TF-IDF vectorized exhibited the best performance on the generic SVC model concerning particularly F1 score, even without parameter tuning. This metric is critical as it provides a balanced measure of the model precision and recall. The model tuning process involved a systematic approach to selecting the most appropriate kernel function, conducting a grid search to identify the optimal values for the regularization and gamma parameters, and choosing the most effective vectorization technique. The selection of the lineal kernel, the comprehensive grid search, and the TF-IDF vectorized collectively contributed to developing a robust and efficient model of the task at hand. The performance of the model is presented in Table 1. This metric comprehensively assesses the model's ability to classify fake and real news articles almost correctly. The confusion matrix is a table that displays a number of true positive, true negative, true false positive, and false negative predictions made by the model. It provides a detailed view of the model's performance by showing how many instances of each class were correctly or incorrectly predicted. The confusion matrix is presented in the left figure. You can see it on a slide. The normalized confusion matrix is similar to the confusion matrix, but the values are normalized with the number of instances in each class. It provides a clearer view of the model's performance by showing the proportion of instances of each class that were correctly or incorrectly predicted. The normalized confusion matrix is actually presented in the right figure. The learning curve graph displays the model's training and validation performance as a function of the number of training samples. It helps to identify if the model is suffering from overfitting or underfitting. Overfitting occurs when the model performs well on the training data, but poorly on the validation data, and underfitting oppositely occur when the model performs poorly on the training and validation data. The learning curve is presented on the slide. You can observe it. The false positive rate versus threshold graphs display the false positive rate as a function of the decision threshold used by the model. It helps to identify the optimal decision threshold that minimizes the false positive rate with a maximum and as a true positive, with maximizing actually the true positive rate. False positive rate versus threshold graph is presented in a figure. You can see it on the slide right now. The result indicates that SVC model performed well in classifying COVID-19 fake news on Weibo platform. The model achieved an accuracy 89.07% and an F1 score of the 87.33%. The confusion matrix and normalized confusion matrix provide detailed view of the model's performance, showing that the model correctly classified a high proportion of instances of each class. The learning curve graph indicates that the model did not suffer from overfitting and underfitting. The false positive rate versus the threshold graphs help to identify the optimal decision threshold that minimize the false positive rate with maximizing the true positive rate. So let's move to the discussions. The result indicates a relatively strong performance of the model in classifying COVID-19 fake news. The model's accuracy is 89.07%, and the F1 score, harmonic means of the precision and the call, is 87.33%, indicating a balanced model performance in precision and recall. However, the model's specificity is only 58%, which is unfortunately relatively low. The Matthew correlation coefficient is 0.6264, considered as a moderate correlation. But nevertheless, the balanced accuracy of the model is 72.29%, which is average of the sensitivity, which means recall and specificity. Classifying COVID-19 fake news on a Weibo platform has several significant challenges, so let me talk with you about that. One of the primary challenges is the language and the cultural nuances associated with the Chinese language, which present unique challenges for the text processing analysis. Cultural nuances for the context-specific references may make it difficult for the model to classify the context accurately. Additionally, the data set is often imbalanced with more real than fake instances, leading to the potential bias toward classifying news as a real, affecting actually the model specificity. Another challenge that I also need to acknowledge is the detection of sarcasm and humor, which is the model often misclassified as either real or fake news. Sarcasm and humor often involve a play on words or like a double meaning that may not be immediately apparent to the model. The quality of the label in the training data set also critical for the model performance, as you can understand. Inaccurately labeled instances in the training data can lead the model to learn incorrect patterns, resulting in suboptimal performance. The variability of fake news also poses a significant challenge. Fake news can vary widely in content style and presentation as well. Some fake news articles may be entirely fabricated, while others may contain a mix of true and false information, which is also extremely important challenge. This variability makes it challenging for the model to classify fake news accurately. Additionally, the nature of the news and information changed rapidly, especially during the public information public information crisis, as like COVID-19 is. The model must be robust to these temporal dynamics and accurately classify news even as the situation emerged so fast as it was in COVID-19. Feature selection is another challenging aspect for this task as well. The model must be considered various features such as text, images, user interaction, for example, comment, like, repost, to classify news accurately. However, incorporating too many features may lead to overfitting, while the too few features may lead to underfitting. And lastly, model interpretability is paramount to understanding the model's decision-making process and ensuring that it's not biased and make decisions based on the relevant features. However, achieving the high model interpretability while maintaining high classificational performance is also challenging, so we need to count on that and find the best balance. The study, so let's go to the conclusion. The study's main finding indicates that the developed model exhibits strong performance in several key metrics, including accuracy, F1 score, recall, and precision. However, the model specificity and Matthews correlation coefficient, as well as a balanced accuracy, highlight areas for improvement, particularly in reducing false positive rate and improving the model's ability to classify real news instances more correctly. The novelty of the study lies in its focus on the Weibo platform, one of the most popular social media platforms in China. It has not been extensively studied in the context of COVID-19 misinformation detection. Future work should improve the model's specificity and overall classification performance. This could be achieved by incorporating additional features, optimizing model architecture, or fine-tuning the model's parameters. Additionally, the future studies could explore using deep learning models and other advanced machine learning techniques to improve the model performance further. It would also be beneficial to evaluate models' performance on other social media platforms and in other languages to assess generalizability and applicability in different contexts. In conclusion, the study presents a comprehensive approach to classifying COVID-19 fake news on a Weibo platform. The developed model exhibits strong performance in several key metrics, but also highlight areas for improvement, as I mentioned before. The study contributes to the growing literature on COVID-19 misinformation detection and provides valuable resources for researchers and practitioners. Ultimately, the accurate and timely detection of COVID-19 misinformation is crucial to ensure that the public is well informed and can make decisions based on accurate and reliable information. Our research on the COVID-19 epidemic underscores the importance of addressing the issue to safeguard public health and promote accurate information dissemination. It is imperative for stakeholders, including government, public health organizations, social media companies, and the general public, to collaborate and implement strategies to combat misinformation and ensure that accurate and reliable information is accessible to all. Thank you. I'm going to stop here.
Thank you very much. Thank you. It is very interesting and very interesting, very actually topical subject of the report. Have you question, dear colleagues? Have you question? So thank you, Galina.